Best regards from UTPL, from those who studied at the School of Civil Engineering. In this video tutorial, we will discuss the issue Characterization from hydraulic valves, corresponding to the file of Hydraulics 2. Introduction. The valves comprise from 20 to 30% of the cost of a plant line, as the process and the cost of a given type and size of valves can vary between 70 and 100% according to their construction. Therefore, the selection valve is of a paramount importance in the economics as well as in the operation of processing plants. As the first part, we will analyze it for pressure losses due valves and accessories. The pressure loss of a valve or fitting consisting of A. The loss from pressure within the valve. B. The pressure drop in the inlet pipe is greater than that normally occurs if there is a return valve in the line. This effect is small. C. Pressure was losing in the outlet pipe is higher than that normally occurs if there is no valve in the line. This effect is very large. From the standpoint of experience, it is difficult to measure separately the three faults. However, their combined effect is desired among can be accurately measured and well-known methods. In the next part, we will analyze with regard to drag coefficient K, equivalent length, and flow coefficient. Resistance coefficient K. The drag coefficient K in the equation is defined as the velocity heat loss for a valve or accessory. It is always associated with diameter to which it refers speed. Therefore, the resistance coefficient K is considered independent of the friction factor and Reynolds number, which can be treated as a constant for any given obstacle in a pipe system flow under any condition, including the laminar regime. The following example shows two sections of pipe the same diameter and length. The upper section contains a glove valve. If the pressure loss increase P1 and P2 are measured increment between the point indicated, is that increased pressure P1 is greater than the increase in pressure P2. Equivalent length. The relation L on D is the equivalent length of straight pipe diameters cause the same pressure loss which the obstacle in the same flow conditions. Since the resistance coefficient K is constant for any flow condition, the L value of D for any given valve of fitting must vary inversely with the change of the friction factor for different flow conditions. The resistance coefficient K, in theory, is a constant for all measures of a certain design or line of valves and fittings, if all measures were geometrically similar. However, geometric similarity is unlikely to happen if it varies because the design of valves and fittings shall be governed by manufacturing costs, standards, structural strength, and other considerations. Flow coefficient. Manufacturers and users of valves, control overall, have found it convenient to express the ability of the valve by a flow coefficient Cv. The ratio is related to K by the expression, where Cv is the flow coefficient in the valve gal per minute of water at 16 degrees Fahrenheit. which passes through a pressure drop PSI valve and is the internal diameter of the valve in inches. Selection of valves types. The type of valve depends on the function to be performed, be either closing or blocking, strangulation, or to prevent reverse flow. These functions should be determined after a careful study of the needs of the unit and the system in which the valve is intended. Valve function of valves, which are also called check valves, throttle valves, holding valves, should take into account the selection depending on the service valve is required for liquids and gases, liquids with solids, gases, solids, vapors generated instantaneously by the reduction in system pressure, with no corrosion or corrosion, erosion or no erosion. Building materials. The engineer, after establishing the function and select the type of valve, should consider building materials suitable for the service for which the valve will go. All parts of the valve that are in contact with the fluid must have the necessary resistance to corrosion. To select building materials resistant to corrosion, the engineer must guide them to use as material recommended by manufacturers for various types of services as well as published data. If this information seems to be inadequate, should be obtained corrosion data from laboratory existent. Capacities of pressure and temperature. In this respect, the engineer should compare your choice with list of manufacturers in capacities of pressure and temperature to ensure that fit her. To establish the pressures and maximum operating temperatures, the engineer may provide the ability to pressure required by the valve. The selection of materials suitable for the gaskets is as important as the material of the valve for their intended service. The selection of inappropriate packing may allow the valve to leak and require a system shutdown to replace it. Costs and availability. Many times you will find more than one type of valve for a specific job. When all factors such as building materials, performance, capacity and availability, pressure and temperature are equal, the valve must select a lower price. When the engineer has determined the best type of valve for the service, must take into account the cost and availability. You have to get availability and cost data from distributors or manufacturers. Also keep in mind if there will be variation in the price at the time of delivery. The price of each valve may also depend on the quantity to be ordered in a given time.